Today's lesson is the backwards lesson of yesterday. So yesterday we were given information about parallel lines and asked to solve for information about angles. Today you will be given information about angles and asked to find in there parallel lines. Okay, so it's the reverse process of yesterday's lesson. Yesterday we had a postulate. That was postulate 10. So this is a repeat from yesterday here. And it said, if two parallel lines are cut by a transversal, then corresponding angles would be congruent. So yesterday we started by knowing we had parallel lines, and then we found stuff about angles. Postulate 11 says, if we have two lines cut by a transversal and the corresponding angles are congruent, then those lines have to be parallel. Same picture, but a different starting place. Yesterday we knew parallel, we found out angles. Postulate 11 says we know angles and we're finding out parallel. What's that called when two sentences say the same thing but backwards? Converses. So these are converses of each other. It's the opposite process, different starting information. So then we have a theorem that again is a converse of a theorem that we had yesterday. Yesterday we started with parallels and said then we could know that alternate interiors are congruent. This theorem says if we know alternate interior angles are congruent, then we can say we have parallel lines. We're going to go ahead and prove this. You will not have any proofs in your assignment tonight, but tomorrow the whole lesson is going to be proofs. So we're building towards that.
The whole lesson?
The whole lesson tomorrow.
Oh, God. Kidding.
So the if is our givens. So if we have two lines cut by a transversal, so we've got a picture of that, and the alternate interior angles are congruent. So that's what we're given, is that our alternate interior angles are congruent. So in the picture, which angles are alternate interiors?
1, 2, and 3.
1 and 2.
No.
So 1 and 2 are alternate interior angles in that picture, and so that's our given. This says if those are congruent. Then we want to show we have parallel lines. Okay, so 1 and 2 are congruent. Looking at the picture, which other two angles have to be congruent no matter what?
2 and 3.
2 and 3. Why? What are they?
Vertical angle.
Vertical angles. So then 1 is congruent to 2, and 2 is congruent to 3, which means what?
3 is congruent to 1.
3 and 1 are congruent to each other. What's that called?
Same side interior.
Transitivity.
Well.
Or substitution. So when we set up that process of 1 equals 2 and 2 equals 3, so 1 equals 3 when we're following a chain of equality or congruence, that's called transitivity or substitution. Now if we look at the picture, what kind of angles are 1 and 3? Corresponding angles. And postulate 11 said, if corresponding angles are congruent, then the lines that are making them must be parallel lines. So we can say now that K is parallel to N because of postulate 11, which says if corresponding angles are congruent, then we have parallel lines. Questions? So that's two ways that we can look for parallels. We can look for corresponding angles to be congruent, or we can look for alternate interior angles to be congruent, according to this theorem. Several more theorems here that can tell us about parallel lines. Theorem 3.6 says, if the same side interior are supplementary, then the lines are parallel. That again is a converse of something we had yesterday. Theorem 3.7 says two lines that are perpendicular to the same line have to be parallel to each other. That also is a converse of yesterday. Yesterday we had one that said if we have parallels and a line is perpendicular to one of them, it's perpendicular to the other one too. So this says if I have a line that's perpendicular to two lines, those have to be parallel. So it's turning that statement around. The other three are new for today. They're not converses of things from yesterday. 3:8 says, through a point outside of a line, so I've got a line and I've got a point that's not on that line, there is exactly one parallel. So this says there's only one way to draw a line and through that point that's going to be parallel to the other line. This makes sense when we think about our world. So like if we look at the bricks on the wall, we got the bottom of the brick, there's only one way to make the top of that brick so that it's going to be straight and level. If that line was leaned at all one way or the other, it wouldn't be straight or level. There's only one parallel there. This theorem is actually really interesting though because mathematicians have spent a long time thinking about what if this isn't true and have kind of come to discover on the grand scale that it isn't. Up close in our world, it's definitely true. Drawing things on sheets of paper is definitely true. But we live on the Earth, which is a sphere. And so if we draw two lines on the ground, they may look very parallel to us. But if we can zoom out to space, since it's on a sphere, they're actually rounded lines. And this theorem starts to do some interesting things. If you're doing honors, studying this might be an interesting thing for you. I find it very fascinating. And that would be studying what's called non-Euclidean geometry, where there's possibilities of having more than one parallel line, or less than one, that there actually is no such thing as parallel. Theorem 3.9 says, through a point outside of a line, there's one way to make a perpendicular. And theorem 3.10 says, if I have two lines that I know are both parallel to another line, then they are actually parallel to each other as well. In today's assignment, you are going to be given information about angles and asked to find sets of parallel lines. There are 5 ways that we can say that we have found parallels. We can look for corresponding angles that are congruent. We can look for alternate interior angles that are congruent. We can look for same side interior that are supplementary. We can look for them both being perpendicular to the same line, or we can look for them both being parallel to the same line. 5 ways that we can show that we have found parallel lines. So in our first problems, it says state which segments, if any, are parallel, and then we want to justify our answers here. Do not trust your eyes on your assignment. There are going to be several lines that look parallel to each other. They are not necessarily according to the given information. So if I just look at this picture, I would say, yeah, top and bottom are parallel, left and right are parallel. Like it looks all nice and straight. But given our information, that's not necessarily going to be the case. So what we need to do is look for special congruent angles or special supplementary angles. I don't see any angles that are congruent in this first picture. Do we see any that are supplementary? But add up to 180.
Wait, can we do the shake too?
Yeah, so just inside of this first one, are there any angles that would add up to 180?
K and C.
K and C do not quite,
D.
but K and D do.
Yes. 180?
Add up to 180. So if I draw those two angles and say that the 118 plus the 62 equals 180, what kind of angle pair are those? They're supplementary, but according to our lines, what did we name them? Same side interior. And we had today a theorem that said if same side interior are supplementary, then they make some parallel lines. The lines that they make parallel should be lines that we traced out. We did not do anything with line CE, so we don't know anything about that line, but we can say that KC is parallel to DE. Our justification would be if same side interior angles supplementary, then parallel. Are there 3 next here? I think I'm allowed. Can I get these? On the next one, if I start to look for congruent angles, they're not quite there. I got 50, 52, 30, 28. If I start adding up to 180s, they don't all add up to 180. But there are actually still some congruent angles in this picture. Does anybody see where we do have some congruent angles in this picture? Yeah.
Angle O and I.
Yeah, the full angle O and the full angle at I are both 80s. 50 and 30 make 80, 52 and 28 make 80. So if I trace out those full angles, I'm going to ignore those lines that are coming in at the slants because they don't matter for the full angles. Then what kind of angle pair are those? Corresponding angles. And we had a postulate that said if our corresponding angles are congruent, they make some parallels. So the parallels they would make would be OX and IZ. And we would justify that by saying if corresponding angle is congruent, then parallel. It looks like OW and IY are parallel as well, but we don't have any information to justify those lines. Questions on these? Okay, in the next one with LAST, if I look for some congruent angles, I see the 46s. So if I start tracing out the 46s, I get a triangle which has no parallel lines. So that's not helpful. I don't see any other congruent angles right away or any supplementary angles right away. But there is something going on here. So what can we do here?
Oh. 46 and 44, they equal 90. And then there's a 90-degree angle.
So we had a given 90 at the bottom, and if we put together those two angles at the top, they make 90 as well. So we end up with this picture. So then we can say we have some parallels. We can say LA is parallel to TS. There's two different reasons we could apply here. Those are same side interior angles. So we could say if same side interior angles supplementary, then parallel. Or we could use the theorem that talked about perpendiculars and say if two lines perpendicular to same line, then parallel. Because those two lines are both perpendicular to AS, so they must be parallel to each other. Both of those reasons would be correct justifications. And the next one I've got a 90. I have 49, 48, 44, so nothing is directly equal. We've been doing a lot of adding, so if I would try to add these up, that is 92. So that's not really helpful either. There's actually no parallel lines in this picture, and that's an okay answer too. Let's state which, if any, are parallel. So it kind of looks like a square, but it's not necessarily unless we have something that we can prove it with. The next group of problems are very similar to your homework. In your homework, all 16 questions are going to give you information about angles and ask you to try to find parallel lines. Again, none is a possible answer. You will be using the exact same diagram for all 16 of the homework problems. So again, it's important that we don't trust our eyes because in that diagram, there's several sets of lines that look like they could be parallel. But we only want to base it on what that particular question says. Okay? You do not have to justify in these problems or in your homework. You just have to find parallels if there are any. So my strong suggestion is to trace out what you're given and see just that part of the picture so you can lose everything that's extra. So for the first one, I would trace out angle 1 and angle 8. And so if I was drawing this in my paper, don't necessarily trace it in your book, but you can just draw out what that would look like if all we drew was angle 1 and angle 8. I would see this. Those are alternate interior angles to each other, which make parallel lines. And the lines that they made were PL and AR. We don't have to justify them, but as we go through these, I will say why they are. It's important to think about that these are alternate interior angles, but you don't have to justify them. For the next one, if I trace just what we're given, angle 2 and angle 7, I get a Z. Okay, so on your homework, that's what I would expect to see, like in the margins of your paper. We're going to see lots of Z's and N's and zigzaggies and maybe some triangles, maybe some other stuff that doesn't work, but we're just going to see lots of little sketches of just what we're given. 2 and 7 are alternate interiors, which makes them parallels, but they make different ones than last time. Those lines make PA and LR.
So we have to write those or draw those?
You don't have to, but I think you'll probably do better if you do. Just for your own benefit, to kind of be able to narrow down the picture. Some people are better at seeing things in their heads. I'm not as good. I kind of have to see it on paper. The next one, 5 and 3. If I look at angle 5 and angle 3 and I trace those out, that makes a triangle. Triangles do not have any parallel lines, so that's none. There might be parallels in that picture, but our information doesn't tell us that there are. So we're not guaranteed anything. Angle 5 and angle 4 for the next problem. I trace out angle 5 and angle 4. I get an N. 5 and 4 are alternate interior angles, and the sides that I traced out are PL and AR. Questions so far? Problem changes a little bit now. It says 5 plus 6. So that means we're combining some angles together. So what we can do is say 5 plus 6 creates that whole upper corner at P. And 3 plus 4 creates the whole lower corner over at R. So if I would trace that out, I'm saying this angle equals this angle. It is tempting for students to say that both sets of lines are parallel here. But that's not the case because those are not a special angle pair. We don't have anything to call those. Those are not corresponding. They're not same side interior. They're not alternate interior. They're no special angle pair. So we don't know whether or not we actually have any parallels here. So this is none. We have to be able to bring it back to one of those kinds of special angle pairs. If you can't do that, then it doesn't really work, even if it looks like it does. So you don't have to justify on your homework, but it's probably good to at least think about it while you're doing it. The next one says APL, which is that whole upper corner at P, and PAR, which is the whole upper corner at A, and they add up to 180. So this angle and this angle together add up to 180. What kind of angle pair are they?
Supplementary.
They're supplementary, and according to our line names for angles, what kind are they?
Same side.
Same side interior. So if we have same side interiors that turned out to be supplementary, that's a good thing because we had a theorem that talked about that. So that means we do have some parallels here, and they are PL and AR. And our last one says 1 plus 2, which in the picture are next to each other, so I can just go ahead and combine those together and say that that is the whole angle at L. And 5 and 6, which are next to each other, so I can combine that together and say that's the whole angle up at P. And it says if I take those and add them together, I should get 180. So this is like the last picture turned on its side. They're still same side interior. They're still adding up to 180. So that gives us some parallels. But this time, I have different lines traced out. So it's PA and LR. Okay, so on your paper, if you're drawing them all out, we should see lots of Z's and N's and zigzaggies or kind of boxy C things like this on its side where you're drawing out just the angles that you're given and none of the extra lines to distract. So 1 to 16 tonight from section 3. It is possible to get none. Also, towards the end of the assignment, it is possible to get more than one set of parallel lines. That's an okay thing too. So for the majority of them, you will get one set of parallel lines. But it is also possible to get none, and it is possible to get more than one set of parallels.